For this question, you have an electron entering a E field and B field region. So which essentially, right, is here. So this region, right, whenever you see this is meant to be a velocity selector, and you have to be doubly sure also lah. You see the electron actually goes straight through. So here, right, who can get through? Okay, the guy who get through, right, must have a electric force equals to the magnetic force. Okay, and that will mean that BQV equals to QE. So V equals to E over B. So once again, right, you see this is very easy to derive. So I encourage you to learn to derive it. Okay. Yeah, and this charged particle, right, this electron goes into the second magnetic field, which is different. Okay, so let's call this B1. Yeah, and it performs circular motion. So we want to find the radius of the path of this electron in the second field. So with that, right, you see FB provides for FC. So BQV equals to mv squared upon R. So R is equals to mv over BQ. And we know let's call this B2 is the second field. So V, right, we already know is E over B1. So substitute that in. So you know is ME over B1, B2, Q. So you substitute only in this step. Okay. So you have your 9.11 times 10 to the power of minus 31. That's the mass of the electron. Times the E field strength, 1.5 times 10 to the power of 7. Divided by B1, B2, 0.5 and 1.0 times the charge, 1.6 times 10 to the power of minus 19. So you see here, right, you have 1.5 divided by 1.6, that's almost 1, or 0.9 something, close to 1. 9.11 divided by 0.5, there's a doubling. Okay, so you will have something like 18.2. 18.2 times almost 1, so that will give you something close to 18, so that will be a 1.7. So here I'm just trying to demonstrate to you, right, some easy mathematical trick, okay, that you can rely on and super reliable without using calculator, and it's very fast.